Hi and welcome to another Carpenter Tutoring tutorial. I'm Amy and today we're going to work through a couple examples of evaluating algebraic expressions. For each of the problems that we'll work through today, we'll be using the formula V equals the quantity B times C plus D all over 3. But we'll be evaluating it for different values of the variables B, C, and D. Let's jump into our first problem. So in this first problem, we're still using that same base formula. So we have V equals B times C plus D all over 3, but we have set values for these variables. B is representing 5, C is representing 4, and D is representing 1. The first thing that I need to do is change my representation of this formula to show not the variables, but the numbers that they're standing for. And I know what to plug in for those variables based on the definitions that we've been given for this problem. So what I can do is replace the B in my original formula with 5, the C in my original formula with 4, and the D in my original formula with 1. Now, one thing that we have to be very careful about at this point is making sure that all of the operations that exist between our variables are still present between our numbers. And we actually have an issue with this example. When we have two variables right next to each other, like we have with B and C, that's another way of showing multiplication. But when we switch that to a relationship with numbers, two numbers being right next to each other does not necessarily mean that we have multiplication. In fact, if I just saw 5 and 4 right next to each other, I would think that it was 54, not 5 times 4. Because of that, I have to make sure that I represent the multiplication between the 5 and the 4 when I plug in the numerical values for those variables. So I'm going to go ahead and use parentheses around these to show that they're being multiplied, although you could use a dot between them or an X between them if that's your preference for showing multiplication. And then I have to finish the formula, so this is still all over 3. Now that I've plugged in the values for my variables B, C, and D, I can use order of operations to simplify this expression and find the value of V. Order of operations tells me that I need to start with grouping symbols. And when we look at this problem, we don't have any obvious grouping symbols right off the bat, but we actually do have secret grouping symbols. A really important step to remember, especially when we're looking for those grouping symbols, is that anytime you have a fraction, technically, the top part of that fraction, or the numerator, and the bottom part of that fraction, or the denominator, are each within their own grouping symbols. That means I have to simplify any operations happening in the numerator and any operations happening in the denominator before I can move on to actually performing the division. So we'll start with the numerator, where we have 5 times 4 plus 1. In order of operations, multiplication comes before addition, so I'll do the 5 times 4 first. And then I can do the addition. 20 plus 1 is number in the numerator and one number in the denominator. I've satisfied my grouping symbols and I can start working through other parts of order of operations. So the last operation that we have now is division. So we can do 20. The value of V must be 7. Let's take a look at what happens when the values of B, C, and D change. We'll find that the order of steps that we have to take because of order of operations remains the same, but what numbers we get when we simplify each of those steps will be different. So again, the first thing I need to do is plug in the values for B, C, and D in this example. So we started off with BC plus D over 3 again. And now I'm going to replace the B with a -5, the C with a 4, and again I've used parentheses around these to show the multiplication between B and C, and then adding the value of D all over 3. Just like last time, we have to pay attention to the fact that the numerator and denominator are each technically their own groups, so we'll have to simplify the numerator first. Once again, I'll have to start with the multiplication in the numerator because multiplication always gets completed before addition. So negative 5 times 4 gives me negative 20 plus 2 all over 3. Now I can do that addition, so negative 20 plus 2 is negative 18 over 3. And now that I've gotten both the numerator and the denominator to a single number, I can actually do the division, and negative 18 divided by 3 is negative 6. So when I change the values of b, c, and d to negative 5, 4, and 2 respectively, now v equals negative 6. Let's take a look at one more group of values. Now we have a b value of 7, a c value of negative 1, and a d value of positive 1. We'll start off again with our formula. V equals bc plus d all over 3. Our first step will be to plug in the numerical values that each of these variables represent. So b represents 7, c represents negative 1, and d represents a positive 1, and that's all over 3. Again, our order of operations isn't going to change. We have to focus on the numerator first. And within that numerator, we'll start with the multiplication. So 7 times negative 1 is negative 7. That leaves us still with plus 1 over 3. Then we can do this addition in the numerator. So negative 7 plus 1 is negative 6 over 3. And now I'm ready to actually do this division. So negative 6 divided by 3 equals negative 2. So in this situation, v equals negative 2. What we can see with problems like this, where we're using the same formula but changing the definitions of our variables, is that order of operations is going to stay the same with each version of the formula that we complete. The only thing that changes is the values that we get at the end, and that changes because of the differing values of those variables. I hope it's been helpful to go through a couple examples together. As always, if there are any other topics you'd like to see covered, please let me know in the comments below. Be sure to like and subscribe. Thanks for spending part of your day with me, and I'll catch you next time.